Hello guys, here Gabby again. Today we're going to talk about clean architecture in microservices in a specific problem. For example, in microservices, most of microservices do not fail because of performance. They fail because of bad structure, and usually it's not because of clean architecture that's wrong. It's how people apply it that's wrong. Out talking about architecture in microservices, I use a structure based on clean architecture. The goal is simple: change things without breaking everything. To do that, I split the service into four clear layers: API, application, domain, and infrastructure. Let me explain everything. Of API, the thin must be layer. The API is a thin layer. It defines input and output contracts, requests, responses, and parameters. And so, the HTTP pipeline, the middleware, versioning, Swagger, and so on, for example, security. And this is critical. It does not contain business logic. You have to remember that. The API never has to get business logic. No, it's a thin layer with contracts, request parameters, responses, middleware, and so on. Nothing more. Okay, versioning, redirection, whatever. If your API is making business decisions, you already lost control. And that's and why? Why is that? Because now we are going to talk about the other layer, the application layer. The application layer, we use it for use cases, okay? The application layer contains the use cases. This is where we can find the CQRS handlers live, the orchestration happens, this is where the validation runs, this is where the application rules are applied, and this is where ports and infrastructure are defined. The application layer knows what needs to happen, okay? But not how it's persisted or which provider is used, okay? That's very important. The next layer below, we have the core of everything. The core of everything is the domain. The domain is the core of the system. The domain contains entities, value objects, business rules, and domain exceptions. And this rule is non-negotiable, okay? If your domain depends on other things, like, for example, I don't know, Entity Framework Core, HTTP, or Azure, or configurations, or whatever, that's not a domain anymore. That's not a domain. It has to be pure, unique, and business oriented entities. The core of the business is there. Okay. The other layer is the infrastructure layer. Okay. The infrastructure layer implements the technical details, and for example, then the application uses it. The application is the orchestrator and use the implementation, but I don't know, for example, a payment gateway could be from different providers, and the implementation of that gateway for the different providers, that it's done in the infrastructure layer. Here is where we put all the entity framework core, the repository patterns, the HTTP integrations. For example, you can use your own custom HTTP client, your factory, or you can use a library as Refit, for example. Here you can implement cache, for example, Redis. You can use Azure SDKs. So infrastructure changes often. That's why it's on the outside of our scope. Okay, we have the API, the application, and the domain, and so on, the infrastructure. Okay, this is where the separation of concerns matters. Okay, this separation of API, application, domain, and infrastructure allow us to change things, to change providers, to change how I expose the API without touching the domain or the use cases. Okay? Okay? For this to work, we need to follow strict reference rules. These rules are that the API can reference application and infrastructure. Application can only see the domain, and the domain reference absolutely nothing. Nothing. It's pure. It depends on nothing. Okay, the project of the domain that we are going to build in a microservices in this context, it has to be pure. It must not have any project reference of any sort. And finally, the infrastructure layer reference the application to implement those interfaces. Okay, so we have the API that could reference only application, but we can reference application and infrastructure. For example, we need to call only an external provider with no use cases, and it's very simple, and we need it to do it on the outside. We call directly to the infrastructure, for example. But if not, we use the application that has that is the orchestrator, and we have the interfaces, and implementation is on the infrastructure side. Okay, so we have the API, okay, that references application and infrastructure. Application reference only domain. Domain is pure, and infrastructure references application. Okay, these rules are not optionals. For example, as I said before, we could have a real example. I don't know, we are working with payments. Okay, we defined interfaces like an interface like payment gateway in the application layer. The concrete implementation lived in infrastructure. The application never knew whether it was, for example, a popular SDK here in Argentina, Mercado Pago or EMOC or so on. Okay, that's real decoupling. We have an interface of a gateway of payment, and it could be any provider. I can make a payment. I can use a payment for Mercado Pago, for other provider, and so on. It decouples and it doesn't know. Okay. Other thing to add more context and value. For example, if we are talking about more about object, DTOs, contracts, business logic, that is, for example, in infrastructure, the HTTP contracts live really exclusively in the API. What I mean with this is that because they are a transport concern, in the API, I map those contracts to internal DTO using, for example, a library Mapster, and then we send them to the application layer. The business logic never lives in the API. Every business decision, complex validation, or rules lives or in application or in domain. I prefer use cases in application, to me. We have a payoff. That way, if tomorrow I switch from REST to GraphQL, for example, or messaging or events or whatever, we don't touch the domain or the use cases. That's very, very important and useful for us. Everything that is cross-cutting lives outside the business logic. Okay? For example, exception handling, login, correlation IDs, idempotence, telemetry, and we implement those things using our middlewares or pipeline behaviors. Never inside the handlers and never inside the domain. We have an example. We have an exception handling middleware that converted domain exceptions into our famous problem details, and the correlation middleware that propagated the correlation ID to outgoing HTTP calls. Okay, that's an example. Closing the loop, we can say that the first layer that we talk about, the API that we thin, the API must not be fat. Okay, so it's thin that it's not fat. To prevent to prevent the API from becoming fat, we try to keep we could use minimal API or controllers. Let's say we use a minimal API. No, we keep the endpoints very simple. The endpoints must receive the request, validate minimal structure, map to a command or a query or a DTO. Okay, for example, we have the contract we map it to a DTO that perhaps the DTO lives in the application layer because API reference to the application. Execute the application. It has to do what it has to do, and then we return the result. Nothing more. Input, some changes over validation, transforms, execution, and returns or mapping. Okay, that's it. So we have a list of bullets about this talk. That is that the domain does not that must not depend on anything. Infrastructure always changes. The API must not contain any business logic, and that's why application defines interfaces. Okay. And okay, that's it. I'm Gabby. I'm a backend engineer, and I like to build microservices. And I hope this helped you. And give a like or subscribe or do anything. It's okay. Thank you so much. See you next time.